Hello, my name is Mark Gibson, and you're listening to the podcast version of the Teagasc Signpost Series, a weekly webinar that promotes and examines sustainability in Irish farming.
Good morning, and you're very welcome to this morning's Signpost webinar, which is brought to you in association with Dairy Sustainability Ireland, Food Drink Ireland SkillNet, and National Rural Network. This morning, I'm delighted to be joined by Dr. Lilian O'Sullivan, who is a researcher in integrated land use and soils based at Johnstown Castle. Lilian, you're very welcome. Lilian, you've spent a good bit of the last few years digging out and trying to understand and quantifying hedgerows.
Yeah, so I suppose today the focus of my talk is really around looking at the climate regulation potential of hedgerows. People are very curious, I suppose, about that. It's become very important, certainly in the policy space, but also too at farm scale, as you know, farmers are all trying to adapt to try and meet all of these targets and support meeting and addressing some of the challenges, not only for biodiversity, but certainly too for climate, and certainly hedgerows have a role to play in that. And that's the topic really of this morning's presentation in terms of the project we did and just what we found out and how we can use that knowledge. And of course, we'll always conclude with some of the remaining knowledge gaps, of course, but we've made some progress at least.
Okay, and a huge interest in the topic, given that you have acres now with planting coming up, you have potentially some planting coming up under eco scheme, and you have a lot of further regulation in terms of the management of hedgerow for derogation and for farmer stocking at significant stocking rates. So a lot around the policy piece in relation to hedgerows. I suppose without taking up any more of your time, Lilian, if you're okay to go ahead with your presentation.
Okay, very good. Thank you very much, Pat. Again, delighted to be here, obviously, as part of Hedgerow Week, which, of course, has been growing in the last number of years, and people are really starting to appreciate and understand the value of hedgerows. And just following on from what Catherine mentioned there, before I get into the carbon component, I just think this is a very nice picture from the UK, the People's Trust for Endangered Species, where they really show and highlight here in this image all of the many very different ecosystem services that we actually get from our hedgerows. You know, they have a role in terms of crops, soils, reducing erosion, livestock, animal welfare, you know, shelter and shade. All of these things that I suppose we don't always immediately think about. And of course, they also have cultural and aesthetic value. But today we're going to focus, as I said, primarily on that whole area of carbon and carbon storage and a bit on sequestration as well. But I just think not to lose sight, I know, as you mentioned, this area of carbon has become very important, but it's really important too to not lose sight of that very diverse range of services that we get from our hedgerows. But I suppose in relation to hedgerows, why do they matter for climate? Here on the left, I show a picture of the carbon cycle, and of course, photosynthesis draws carbon dioxide from the atmosphere, and that carbon dioxide is utilized then to grow biomass, such as grass, trees and crops, and some of it, of course, ends up getting locked into the soil. And of course, hedgerows, you know, they're an important woody biomass feature that we have across our landscapes. And they too lock up carbon in that plant biomass and in the soil over time, and they're sequestering during that active growth phase to maturity. So then I suppose in terms of the research context, you know, we've touched on this. I've updated it even from when we were doing the project actively. It's a rapidly changing policy environment. But one of the issues that has been coming up over the years is the fact that we, you know, have not had capacity to be able to account for hedgerows within our national inventory reporting. Currently, they fall within the grassland and the cropland categories. But to be able to do that, we need to be able to advance our capacity to assess carbon stock change over time. So from point A to point B, what's happened? Has that carbon stock gone up or down? And depending on what's happened in that interim phase will dictate in that emission reporting part whether it's a source or a sink. At the national scale, We're all aware that we have the Climate Action and Low Carbon Development Bill, which has an economy-wide target of 51% carbon reduction emissions on 2018 levels. And we know that that target for agriculture is 25%, but has not yet been set for the land sector. So again, hedgerows play into that space as well. And that land use change and forestry sector is actually quite challenging for Ireland, because unlike the rest of Europe or most of Europe, that land sector is actually a source of emissions in Ireland. This is primarily to do with drained organic soils and other matters. But what it does signal to us is that if we have carbon sinks, we need to look after them and we need to try and optimize them. And if they're losing carbon, we need to stem that loss. Of course, hedgerows have been part of different agri-environmental schemes for a long time. And Pat referred there now to the opportunities opening up within eco schemes. We know there's budget under acres, etc., for planting new hedgerows. But I suppose in summary, in general, hedgerows have been somewhat overlooked in climate policies, but they have been afforded protection under cross compliance. And of course, they're protected under the Wildlife Act. But this is a trend that we often see in that policy space, is that, there's very often that lack of integration. So I suppose historically you might have had payments that, that you can't have hedgerows encroaching into the area, etc. But there's been quite an evolution in some of that space, now recognizing that we also have other targets that have to be met, whether that's climate, biodiversity, and so on. So there's kind of a new appreciation or looking at some of these landscape elements like hedgerows differently. It's fair, there's been a lot of work done previously in this space. In terms of quantity, it's important, if you want to account for hedgerows, you need to know how much is there. And there's been a lot of previous projects within Teagasc and in collaboration with other partners to trial different technologies to be able to get estimates on what the extent of hedgerows is in Ireland. The Briar project, one of the more recent ones, had an extent of 689,000 kilometres. But all of the evidence would suggest that there has been some decline, or there's a rate of decline in that hedgerow stock over time. So what some evidence would suggest is that rate of decline is going down. However, there was a revisit or a resurvey of the County Monaghan hedgerow survey published in 2021 that showed that there was a contraction of 0.9%. So this issue of losing hedgerow stock seems to be out there in the evidence, and also the quality of some of our hedgerows. There's research been done by a former PhD, Julie Larkin here, that shows that hedgerows are on intensive farms tending to be of low ecological quality. But I suppose the positive part of that is that there is opportunity to improve our hedgerows with respect to the multiple benefits. And of course, that's the type of discussions that have been happening around the country this week as part of Hedgerow Week. So just to give you an overview and to acknowledge our funders, the project I'm talking about today is the Farm Carbon Project. It was led by Teagasc, working in collaboration with our partners first. But of course, like any projects, we get a lot of support from our field and laboratory teams here in Johnstown and in Oak Park, and also thanks to land managers who also, of course, fed into this work and supported us to achieve the outcomes of the project. But because the focus is on carbon, it was really about that aspect of how can we try to assess carbon stock change over time. And this was with a view to our inventory reporting. Can we move in the direction of being able to account for hedgerows? But one of the things, even though there had been research to see which were the tools to take remote measurements and what are the possibilities there, we still needed to do some direct measurements to validate, if you like, those remote measurements. And to do that, we had to do a field campaign and quantify our above ground and below ground biomass, analyze it for carbon, but also look at the soil under the hedgerows and if there's any change in that compared to the adjacent land use. We needed to take an airborne survey so that we could relate that above ground biomass to what we would call a projected volume from the remote measurement. And using the two together, come up with equations so that if you have a remote measurement, you can calculate the amount of biomass, which we understand then through our measurements represents a certain carbon concentration and stock. We also looked to test it for an inventory framework. We looked at some of the process-based soil models that are widely used, and we looked at trying to develop an integrated scorecard for assessment. So what is a hedgerow? I know this probably seems like a relatively redundant sort of a question. We all know a hedgerow when we go out and look at one, but I think it's important to mention that in terms of inventory reporting, etc., there is quite strict criteria on how hedgerows are described, and different projects use different width assessments, but there is a hierarchical approach that starts at forestry, and then if it's not forestry based on the width, length and aerial dimensions, then it falls into different types of categories. While the biodiversity survey of hedgerows looks at this at the ground level at 4 to 5 meters, because we wanted to capture the majority of what we the widest range, if you like, in terms of the study, we used up to that 20-meter width, but that was including the vertical profile and the tree crown width. But again, just to remind you that currently within inventories, our hedgerows are in that grassland and, cropland, that should be cropland and grassland categories. Okay, so then what did we do when we went out to the field? It's important that it's not simply a question of just looking at all of it together. When you're there, you need to actually separate out the different types of biomass into the different pools that are assessed as part of the good practice guidance under the IPCC inventory rules. So that means that we had to separate our living biomass into our above ground and into our below ground, so our roots, and then you have your above ground biomass. But you also need to look at dead organic matter, so your dead wood, and that also includes your leaf litter, so litter that's been coming off as part of the growing season, and then in the soil looking at the soil carbon. And then, of course, prior to all of those measurements, we would have taken an airborne survey to know the precise and characterize the hedgerow from which we were going to take the sample. So obviously, in principle, the projected volume is assumed to relate to this volume of above ground biomass. But we know, of course, that management is going to impact that. We also did a process to disaggregate hedgerows into profile types. We used irregular, which was less than 4 meters, and then anything greater than 4 meters was irregular. The reason being is that they're actually quite different, and our irregular, much wider hedgerows, they tend to have a lot more gappiness in space, but have a much larger biomass area. So they tend to be very different from those very regular, very manicured, if you like, hedgerows that we see across the country. So just to give you an example at each site, so we had 8 sites altogether, and at each site, we randomly selected 5 zones for sampling, and they were 6 meters each. You can see here the little trays. This was for collecting litter as we went during the autumnal period until there was no more litter loss. So we routinely collected the litter because that has to be characterized in its own pool and separated out into leaf and some of the slightly more stemmy biomass. So we had to collect that throughout the leaf fall season. And then on site, when we did the actual extraction, it was to separate out, we separated all that above ground living, the dead wood that was attached, dead wood that was loose. Everything had to be weighed in its separate in its separate pools. And of course, there was a whole process of chipping and chipping down and drying, etc., before it could be fit for purpose for the lab. Now let's see. Okay. Now, of course, because it's also below ground, biomass is important. At the sampling zones, we also collected the below ground biomass, or root biomass. So there was a lot of, I suppose, engineering solutions and so forth that we had to come up with to try and do this work. For example, in terms of the air spade. So, you know, you have to remove all of the soil from the roots because you can't have contamination, because obviously there's carbon in the soil too. So, you know, once we had that, the roots extracted and air spaded, we also had to wet sieve roots, and any fractions less than 2 millimeters had to be removed. So very, very tedious type of work there, but that 2 millimeters goes into a different carbon pool. So there's a lot of processing had to happen with all of this. And of course, everything gets weighed, dry weighed, chip down to the level where it can be actually analyzed in the lab. And here you see some of the samples in the oven on the right, but here too, you can see some of the bringing home some samples from the fields there. And in the end, all you need for the LECO, for the carbon analysis, is this very fine ground dried biomass that really only requires a very, very small amount to go through the lab. So you need to make sure you're getting a well homogeneous sample mix in there too. Of course, we also, as I mentioned, took the soil sampling, so bulk densities. As you can see, the weather wasn't great for some of this work, but we took the soil samples under the hedgerow, which was quite difficult because of all the root biomass, but also we took it in the adjacent land use. So then I just wanted to highlight a couple of things here. As I mentioned, the irregular and the regular, we had to profile these hedgerows different because they are quite different actually in reality, also in terms of the amount of carbon that they contain. And while the kilograms per meter squared is not significantly different, the absolute amount of carbon stock varies quite a lot, with the irregulars having a lot more carbon. And this stands to reason because, of course, these are much bigger, much bushier hedgerows with a lot more trees contained within them. So it's just a flag that, you know, it's quite simple, really. More biomass equals more carbon. One of the things was that the carbon concentration was consistent, almost 44% across all of the biomass. So I think that was a helpful finding. It's quite well known, but it was important that that was what we found too, of course, here in this work. So then the objective of relating that measured data to a remote measurement. So we had taken at that time the remote measurement to get that projected volume. And what you can see here is that for our regular sampling, the steeper slope indicates, so these are our regular hedgerows versus the blue, which are the irregular hedgerows, that these regular hedgerows, they're generally more dense and occupy a smaller crown space. So that's why it looks steeper in this model. But what you see in the bottom one is we can improve the model slightly, where we can account for this open space. But in the absence of having actual photographic imagery and all of these things to do that, the model performs well enough in terms of actually being able to just take a remote measurement and use an equation to now relate it to an actual biomass, which in turn relates to a carbon stock. Okay, so then we proceeded to take a look at how can we, you know, test this potentially for an inventory system at a larger scale. So one of the, I suppose, the challenges is that we don't have survey data or necessarily legacy survey data too that allows you to see what's happened, you know, over time everywhere. But one of the tools that we used the National Forest Inventory, which has a permanent grid sampling at 2 by 2 kilometers. And we took 2 time steps where there was data available in 2015 and 2019. And essentially using these equations that we've developed, assessed how that biomass has changed, i.e. the carbon has changed over time for different hedgerow types and management regimes in a pilot study area. So we have the sample, we have it at 2 points in time, as you can see here on the left. There's been a survey done so the projected volume of that is known at 2 time steps. It goes through this process of classifying it, and then applying the equation to see what has happened between those 2 time steps. So we did it, as I mentioned, for the NFI data for the 2 time steps in 2 counties. And what we find is that actually, what you can see here, if we go to the bottom of this image on the left, is that sometimes it's not that necessarily a hedgerow is removed, but what we can see in many instances is there's quite an aggressive, if you like, cutback or removal. So a shift to a very intensive management regime that results back, like in this case here, as you can see in this example, the hedge was cut back to a width of 6 meters from 17 meters. So of course that does signify a loss of hedge volume and biomass, and of course in turn then carbon. So when we put all of those results from those 2 time steps together, what we can do is characterize those hedgerows, and for different types of hedgerows and management intensities, we can assess what's happening and assign a value to the different types of hedgerows that we see. So what we see is emergent hedgerows. They're very good for accruing over that time period carbon, so they're really important. So new hedgerows are really important. Thereafter are irregular, less, I say unmanaged, but it's what we mean is much less intensively managed or not touched. They show to accrue carbon well, and also the regular unmanaged. So that's kind of the order. And what that tells us straight away is that, of course, how you manage this resource is a very direct impact on what the carbon balance is going to be. Of course, then where we have more intensive management, those showed over time to represent losses, and the largest biomass losses were due to the removal actually of some of these irregular hedgerows. And on balance of that pilot study area, we end up with a carbon loss. And this is due to that cutback and removals compared to the stock gains. And I think this is important, that it takes time for carbon to accrue. So maybe some of the newer hedgerows were still very small, but I suppose the big picture with this is, if this is the trend across the country, what you're looking at then, and potentially in inventories, that hedgerows could, from point A to point B, represent a loss versus a stock of carbon. So that's important to keep in mind. Okay, so then in terms of the field, the summary of that part of the work, we completed the campaign, and what was good, as I mentioned, was that carbon concentration for all the dry matter pools was consistent, 43%. Now, if we look at hedgerows as one, the average stock we got was 58 for above ground and 10 for below ground tons of carbon per hectare, respectively. But as I've shown already, there's a very, very wide range between these 2 different profile types. So for these regular, very tight, very routinely managed ones, it's down in the 30s was what that carbon stock tonnage per hectare looked like, whereas that goes up to 70, 80 tons of carbon per hectare for these much bigger, more irregular, less intensively managed hedgerows. We did have some difficulty characterizing the above ground to below ground biomass ratio, because this is quite affected by the management. So what the management is happening. So it's not a linear relationship as such. but we still were able to develop a model or a model or an equation we could use. But from this work, we do have models developed now for 2 major hedgerow types. We've shown that they can be effective for assessing carbon stock changes over time. And of course, cutting back reduces sequestration potential. But the other side of that, of course, is changes in management could enhance potential. So then we just obviously, I suppose the primary aim wasn't to go around looking at all the different farms or anything as such, but one of the things we did do was to look at some of the average statistics that we have from the National Farm Survey in terms of our typical farming systems and the typical amount of area that hedgerows occupy on those farming systems. And here you see that data on the left, and you're talking about 2.7%, of the utilizable agricultural area of 61 hectares, for example, in this dairy farming system is actually hedgerow, and so on. But of course, our dairy, beef and tillage have very different emissions profiles. And when we just kind of look at that in terms of what's the equivalent carbon that those hedgerows on an average basis could have versus the overall amount of emissions associated at farm level with that farm, we can see that, that's 7% for dairy, because obviously it's a much higher emission profile for a dairy farm, but going up to 43% on a tillage farm. So if we were to change management, the management regime, if we assumed everything was regular, so here we're assuming all of the hedgerows are regular, but if we change everything or half of them to being more irregular, there are significant gains to be there if we 50% or 100% of those hedgerows were to switch to a lower intensity management regime. But of course, just to caveat that not all hedgerows are intensively managed, and there's obviously different cultural and other factors that influence what farmers are likely to do in terms of hedgerow management. So of course, it's unlikely that people are going to necessarily all be switching to unmanaged hedgerows. And of course, we still have our roadside safety concerns, which mean that many of the hedgerows will continue to require routine management. So we also looked at the development of an integrated scorecard. So look, we know, and we've mentioned it already this morning, things like results-based payment approaches, they're becoming very integral in part of agri-environmental schemes. And what we did was we did a hedgerow assessment at each of the 8 study sites, utilizing 6 hedgerow scorecards that are widely used and primarily, I suppose, designed for biodiversity assessments, but do have a component or does have variables that have relevance not only for biodiversity, but also for from a climate or carbon point of view. So obviously, the crux with the carbon is really to do with the amount of biomass that's there. So it's things like your width, height, gaps, and management, and so forth. So in terms of that review, all of the scorecards had a number of metrics that were universal, but the grading was very different. So for example, if I recall, the one of the REAP scorecard considered hedgerows greater than 1.5 meters in height to be optimal, whereas in Farm Ecos, this considered it to be 4 meters in height, for example. That's just one example. So there's quite a difference across the scorecards with respect to the same variables. There was high variability in terms of the ecological score, depending on the scorecard used. But I suppose, in short, all of the scorecards had metrics that could be used to assess multiple ecosystem services, including carbon, but the weighting did not reflect their value in terms of the multiple ecosystem services. So then here, that's just to give you a look at ultimately what the variables that we included. the ecological and carbon, age and management, field margins and threats to field boundaries. So it's ultimately, something that could be done quite rapidly, that considers both the biodiversity and carbon functioning of the hedgerow. And then one of the things to mention is more recently, as well as a function of this research now too, my colleagues, Gary Lanigan has recently led the recent version of the latest marginal abatement cost curve for agriculture. And for the first time now, we can include hedgerows and new hedgerows as part of as part of the MAC. So it's now one of the tools in the toolkit of options that we can use to try and help meet our targets. And so based on the soil modelling and the biomass, a rate of 3.55 tonnes of CO2 per kilometre can be applied. And we see that then in the MAC, where we have two pathways were applied, where you have different levels of new planting and also an option for management regime based on the work that we completed. Okie doke. So just to summarise all together, again, it's important that hedgerows in the pilot should be in decline. So this could mean that, if this is the trend universally across the country, then of course this means that hedgerows could be a potential source in our LULUCF inventory. But so current management may be resulting in this net emission from the biomass pools, but less intensive management can result in significant carbon removals. And so that, of course, is things like the new hedgerow establishment, the less intensive management. We know, of course, now there is potential to possibly include hedgerows in the inventories. We now have potential or they are included in the latest iteration of the MAC. And there's also potential to improve some of the existing scorecards to account for more than one objective. We do need some further work in terms of soil sampling to improve the carbon model in the soil. Also looking at potentially the relationship between the above ground and below ground biomass, and also what are the opportunities or strategies from a management perspective, for example, in terms of regeneration, and how can we move forward ultimately to make the most of a resource that compared to many other countries we actually have quite a lot of. Okay, so that's pretty much the overview of the project. So I'll stop sharing now and pass back to Pat there.
I suppose one outcome of research, which is not uncommon, is that when we do research, we find out that how much we don't know, as well as the outcomes of the research. So there's almost always a whole series of further questions arising from research. Just to clarify, I think what you were saying at the end, when we're talking about getting credit for carbon for hedgerows, we're looking at what is our starting point, and whether our starting point is 2018 or whatever the starting point we take. What we're looking at in terms of getting credit in relation to hedgerows is if we build the biomass within those hedgerows to have more carbon in it, we can get a credit for that. But the converse of that is if there is any removal, or if we reduce the amount, we actually have to treat that as a loss of carbon, and that will go against the other measures that we're doing to try and improve. So that in effect becomes a source of carbon from agriculture or from land use.
Certainly, yeah. And that's kind of, I suppose, one of the things that's very difficult for people to appreciate, because they are certainly they are a carbon stock. There is carbon locked up in those hedgerows everywhere. But how at the national scale, how those inventories work is there's base years, they have to be back calculated. There is an issue still there with respect to understanding the management from all the way back from when you have to do the inventories. But another possibility is that it could be included, as they are within grassland and cropland, as a measure within grassland and cropland in inventories. But 100% what you say there is correct, Pat. It's point A to point B. You look at that, has it gone up or gone down? And that's effectively how inventory works. It's from point A to point B. Has there been an increase or a decrease? So that's very much a signal that even if hedgerows are at a state of, obviously their carbon accrual in terms of sequestration is most, while they're in their growth phase. A lot of our hedgerows are older, so they may not be accruing a lot of carbon in a sequestration sense, but they still have an importance as a stock value. And that's something I think is really important for people to not lose sight of.
Okay, and I suppose another issue there in relation to you I suppose dealt with various types of imaging to try and assess and to be able to then ground truth that imaging. And we see, say, for the Department of Agriculture brought out a mapping system which identified hedgerows during this year as part of the eco scheme. How close are we to being able to use the ground truthing that you have and the equations that you have built up to get and to use satellite or LiDAR imagery to be able to do the assessment, possibly rather than trying to do individual scorecards, and to do that assessment effectively as a remote exercise?
Well, usually that reverts back to the issue associated with survey cost. So you can imagine it would be costly. And, while LiDAR would be the best technology to characterize that remote value, it's costly. And we don't have a national LiDAR system per se. How, for example, department would like to proceed in that space is something that's not something I can answer. But what I can say is that those equations are published in a scientific publication now, so they are ready to be used. So, for example, I know I had been talking with one of our colleagues working, for example, in the Signpost farms, and they were doing some characterization of the farms. And so we talked through some of that process, and those were being included then as part of this characterization that was being done where they had the data. But it goes back to that issue of having the data of that survey, the cost of the data, and the repeat of that survey.
Yeah, and making sure the baseline is good enough to do what
baseline, and yeah, 100%. But a lot of those things hinge around cost and a bit outside the control of anything I or you can do, really, as such.
A lot of questions coming in. I know the first question that came in, I think, could take up a whole session in its own right, Catherine.
Yeah, well, I think I've grouped them into. I'm jumping to one few ahead, which will come back to that first question, and it's from a carbon point of view, Lilian, which is what we're talking about today. Is the logical implication of your research that hedges should be left unmanaged?
We have to be careful as such because they are an anthropogenic landscape element, and they're not naturally occurring. There is always some element or dimension of management. But I think what has been historically the case is the intensity of management, but in principle, how to have the least amount of management that allows for the most incremental gain year on year. Certainly year on year flailing is just not allowing you get any further than where you already are, as well as being poor for biodiversity. If you're not flowering and fruiting, etc., you're not really doing as much as you could for a biodiversity perspective, but equally too, you're standing still effectively. So if that's moving, I think everybody's different, every farmer and how they do it is different, but at least if you can move to rotation, or if you can move to some system that's not going to be as intensive, that does allow that biomass to accumulate, then that's the way forward. And of course, I suppose, Catherine, you're more on the ground dealing with the challenges of leaving things go too far unmanaged. That creates challenges, for machinery and other things. So it's finding the sweet spots there in terms of what's the optimum management that allows the most biomass to accumulate. But in principle, less management should allow more gain.
Yeah. Now, just to add my own question on that, Lilian, one key thing you said there was more biomass equals more carbon. And my question to you is that the hedges that you looked at, the managed hedges, I wonder, are any of them like the hedge that we have been trying to propose this week, where you're beginning, layering it up, having dense growth from wide, really tall, but still managed, if you know what I mean. So and I don't think there's many hedges like that in the country at this stage. I assume if more biomass equals more carbon, if I have a 3 to 4 meter high managed hedge, that could be with occasional trees as well, and maybe more occasional than we would have been suggesting. Does that sound good to you?
It sounds good. Of course, I suppose that wasn't one of the types that we had, but it shouldn't matter in terms of using an equation to characterize it, and we would be able to, but it's probably something, the actual knowing a real definitive answer on that is actually something that needs to be looked at over time. And over a time period of 10 years, this is how this performs, and this is how this type of hedgerow performs. That's the level, I suppose, you want to know the answer to at the moment. But none of them were precisely like that, as you described, because there are very few like that.
Correct. And that's the one where, for the people who don't want to go the unmanaged route, the more and also I wonder, sorry now, Pat, if I'm taking over the questions, but I wonder if that one will keep sequestering carbon longer than the one that turns into your tree line hedge and becomes mature, as in mature trees. This one will be forever actively growing a huge, big, dense bulk.
I would say no, because like everything, there is a maturity. When we did the modelling, now the models we used were to assess the net ecosystem exchange. They seem to plateau off at about 50 years. Now, it's important to state that the models we used weren't designed for hedgerow ecosystem, because those don't exist yet. But like all living systems and trees and so forth, there is a point, and it's the same with the soil. People often ask that question. You can keep putting organic matter back into the system, but there is a kind of a saturation or an equilibrium that eventually does happen. So my instinct there would be to say that no, it's not going to indefinitely keep doing that. It will eventually reach a maturity in terms of growth.
But I think one of the points is we're a long way away from that with an awful lot of the hedgerows we have. We've a lot of scope to have a lot more
biomass there. Anyway, so that kind of comes back to that first question you mentioned, the farmer who has all tree line hedges, and amazing to see them laden with fruit, which is fantastic. But about wondering then, should he, I suppose maybe he's been listening to me to say we want both types, and he's wondering, should he do the good top? Now we have to keep saying good topped rather than existing practice. But from a carbon point of view, I suppose, you're tending to have all tree line hedges from a carbon point of view. Look, you're not sure, I suppose.
It goes back to that very first slide.
Yes.
You can't think about hedgerows only from the point of view carbon. What's also, how is that? Because sometimes those tree line type hedges, they're brilliant. But they might be more gappy in parts. And so, how does that affect their benefit in terms of pollution control and intercepting nutrients, which may be some of these other ones that you're talking about.
Better.
So it's thinking about your farms in a holistic way, and what's good for wildlife, what's good for carbon, what's good for all of these things that we do need to achieve. Sure, fundamentally, these hedgerows that have big bushy trees have more carbon. That's the research showed that, and we know that. But I think it's important to not lose sight that there are values to having some mix or matrix of hedgerows potentially.
Provided they're managed,
other services,
provided they're managed better. So I think back to that question, a question came up through our workshops. the farmers own the hedges. It is up to them to decide how to manage them. And what we're guiding them towards is what practices are better and maybe what practices are really bad. It's kind of coming out maybe more useful. Again, planting gaps with trees, obviously, I think Lilian would agree with that. I would just add the Irish provenance in there. Now, a couple of questions then, I'll group them, Pat, about spraying the base of hedges, hedges disappearing from the landscape, all the bad things that's happening. I suppose, comment on that. Is it, is there any consequence? It's not really a question for you, maybe, Lilian, but how do we, there are no consequences legally or financially is the implication from the questions here.
Yeah, but I suppose, again, part of that is the advisory education element to what's really, really important. But I suppose, as we're evolving in what's being ranked as important to deliver from agricultural landscapes, some of those things will be getting more scrutinized, if you like. And I suppose even loss of hedgerows, obviously, there's rules are changing about the amount of replacement planting, different things like that. But I suppose it must be borne in mind that it takes a long time to replace a tree line hedge with some new hedgerow. And so it's everything has to be done judiciously and in a planned way, really, to make sure that you're not, I suppose, upsetting the balance too aggressively.
And again, a comment, and I'm sure you're aware, but maybe it's more the scheme side of it, about the problems that there was where hedges crept out into the field and farmers, for their payments, were cutting them back. So to be clear that that's no longer there, isn't that it, Lilian?
And that's correct. And I suppose that's one of the key challenges with a lot of the policies historically, was that it was, I suppose, focused singularly on a particular delivery. And I suppose more and more the targets aren't just, for example, production orientated. There is a need now to meet percentage areas on farms, etc., for all of these other deliverables that we have to achieve. So I suppose there is greater horizontal integration now, I suppose, or it's certainly moving in that direction, particularly as we have these targets 2030 and now, obviously climate neutrality and so forth in 2050.
Lilian, I have a heap of questions, so if you could just keep the answers short on because I'm not sure if there is answers. Any what's the carbon sequestration from willow versus Sitka, willow growing wild?
Oh, I'd have to look that up, but I know we did have a research project here that looked at willow and miscanthus and so forth. They're fast growing, but so too in the tree world are the coniferous species. But I suppose, the bigger point with that is that there are faster growing species, and that's something to think about too in the planting regime. What are things we could incorporate in? And in other places, they're also looking at certain fast growing species and a kind of a rotational harvesting somehow for a renewable energy type thing. So that's a bit far away, I suppose. But in terms of what you put into the hedgerow, if they're faster growing, they'll accumulate biomass and carbon more quickly.
We heard during the week from Sharon Casey from Cork County Council about the value for biodiversity from the hedgerow banks. Can you comment on the carbon in hedgerow banks?
Well, there is certainly a carbon accrual in the soils and in the banks compared to the adjacent land use, but that's one of the things we do need to explore more, is do a wider soil sampling campaign in relation to characterising the soil element better. But in short, there is an accrual relative to the adjacent management.
A lot of hedges dominated by gorse in certain parts of the country. Do they have any carbon value?
Oof, that's a tricky one. We didn't actually have a lot of gorse in what we looked at. There is, I suppose, some, there will be some in that kind of fibrous biomass. There will be, and in general, for anything we looked at, it was that same carbon concentration. But yeah, I suppose unless you have something to add in terms of the management and the value, the other values, Catherine, there will be some, but yeah, it's not the most efficient.
Pat, do you want to take one or two while I just flick through the ends, try and get the most important key ones?
Yeah, I suppose just a number of questions there in terms of the management of tree-lined And I suppose it comes back down to some degree to the priorities of the farmers as to exactly what they want. There are certain cases where issues like operating machinery close to hedgerows, etc., require a certain degree of management. So I think I suppose one of the big questions that we have in relation to it is do farmers know enough about management of hedgerows at this point, or is it something that we really need to intensively work with them on?
I suppose, I suppose in that scenario, ultimately, if you had a very full one and could get it down to just needing some breasting, that would be the best. But I suppose there's probably maybe at a more general level, maybe some of their benefits aren't fully valued, I suppose, but I can't say that. But yeah. I think in terms of, that advisory education part, it's crucial. And that's not just hedgerows. It's because the goalposts are changing and what we need land to deliver. And so that's going to be an iterative, ongoing process in trying to find the optimal management. What's the way that's going to work for a farmer and for the other things we need to achieve. So.
And just in terms of the amount of carbon per unit area of the hedgerow relative to surrounding grasslands, what kind of relativities are you talking about there? Particularly in terms of the soil carbon.
Yeah, it's difficult to say in terms of the soil, but in mineral soils, we assume a sequestration of about 0.5 ton of carbon per hectare. There's research, the range can go up to 3.9 tons under the hedgerow. Okay. Ours was somewhere in the middle, around 2.8 is but in wider literature, I've seen up to 3.9. So there is carbon accrual, but you have also to remember that it is quite a small area. So the magnitude in total isn't going to be massive. But it's still a benefit there. And I would say there's new mapping, a new map came out from Tal to Éireann, which estimated that national area of hedgerows looks to be around 250,000 hectares. So that's small compared to, grasslands of 4 million plus, so, it's also to keep the perspective in terms of the aerial extent too that these occupy.
Can I come back to one on, because I know you're talking about it's been included in the marginal, the MAC abatement cost curve. And I understand from you that some of the benefit of going from yearly cutting to 3-year cutting is a saving in the machinery costs and the fuel, et cetera, et cetera. Now, apart from, so that's important, I think, for us to note. But apart from that, then, do you think the carbon from annual cutting versus 3 to 5 year cutting, so apart from the fuel saving, which is very important, is the cutting of the hedge itself going from 1 to 3 to 5 years?
Yeah, there is saving there.
There is saving there.
There is, certainly in terms of the carbon accrual. One thing that is interesting, though, is that the year-on-year flailing, that does have returns to the soil. So that's an area where that very routinely managed does actually potentially have a bit more carbon, because if those cuttings are going straight back into the litter component, back into the soil. But certainly again, the best or the fastest saving is that management.
Now, again, I wonder if that's incremental cutting we saw up in Caffrey with Brian Irvine, and they're very much into, and it's what we'd always recommend is never going back to the same spot to cut, so incrementally cutting. And I wonder if what you were measuring was being cut to the same level each year, if you know what I mean. So and just, would you, do you want to comment on that? Was it incrementally, when you could talk about 1 year versus 5 year, if the 1 year is incrementally cut out an inch more each year, allowing them to multiply, would that be, maybe I'm getting too much detail now, Karen.
I know you always want the answer to this question, Catherine, but until we actually look at that,
that's fair enough. And
can I just
make I would say anecdotally, Catherine, when the hedge cutter goes in, It pretty much goes to the same point.
Well, we're saying absolutely not, Pat.
But now I'm saying
yes,
practice is.
I agree. So my
happening.
point is, if we can change practice there, maybe we can be. And just the last point on that one now, because we are on the just to be very careful for the warning for the general thing of moving to 5-year cutting and ending up getting very rough cuts. There's a serious concern about disease in hedges, and we could lose our whole hedge. So as you, Lilian, you're so rounded in everything you say that we need to be careful with everything we do. But so that's Pat, have I missed anything?
Catherine, there's just one comment.
Yes,
and
please.
I suppose it comes from traveling around the country a bit with you this week, and it relates to, we talk about unmanaged, but to get to the point of having a hedge that's unmanaged, there's a good bit of management involved. Particularly at the early stages of planting hedges. It's not a case of put them in, walk away, leave them forever. There's a good bit of management, and people who are going to be involved in planting hedgerows need to have a really good understanding of that early stage management, or if you're getting involved in laying or coppicing or any form of rejuvenation of hedges. There is a knowledge base required there to be able to do that, to be able to do it effectively, to get best results.
Yeah, absolutely.
I think we've come to the end of our time. I would like to say thanks to Lilian. I think a lot of people really appreciated the insight that you've given us into hedgerows. For a lot of people, it's a very new way of looking at hedgerows that I suppose up to a few years ago we weren't thinking around them in carbon, and then we probably over thought about them or overestimated potentially what their role is. And I think now with your data, we're getting back to I suppose a more balanced view of what they can do for us. But also it gives us a starting point to hopefully over the next number of years improve the management to increase the amount of sequestration. So thank you very much. Thanks to our audience. Just in relation to next week, we're going to be joined by Dr. Rachel Catano talking about digitization of advisory services to support sustainable agriculture, and a huge amount of work going on in the space of digitization and digital systems within our organization and within other organizations to try and support. And part of it is in what you were talking about there in terms of the whole use of it's big data in some respects. So a lot of I think the progress we're going to make over the next number of years is going to be dependent on digitization. So we look forward to that. Thank you for joining us. Thanks very much.
You've been listening to the podcast version of the Teagasc Signpost Series, the weekly webinar that promotes and examines sustainability in Irish farming. Don't forget to join us live every Friday morning for our latest webinar. For more, visit teagasc.ie. And you can also rate, review and subscribe to the Signpost Series on Apple Podcasts, Spotify or wherever you get your podcasts from. I'm Mark Gibson and thanks for listening.